to consult itself with a specific location where the container is executing. If the image will fail, Kubernetes will know, and you will try to make sure that the application will get up as soon as possible back on the desired state. It can also provide a built-in way to distribute traffic between replicas and perform zero downtime routes. You instruct those commands to the API server via kubectl or some other tool. We will look into our application how we can then build our own tool that will interact with those specific APIs. Because the API server is the only one who can interact with ITSI. ITSI system is at the heart of any Kubernetes cluster. It implements the key value store where all the objects in a Kubernetes cluster are persisted. The Kubernetes APIs, in short, are a RESTful API based on the HTTP and JSON. If you know how to talk with HTTP, JSON, if you know how to authenticate, you can basically do everything in Kubernetes cluster. API server is relatively simple to manage because all of the APIs server's persistent state is stored in a database that is external to the API server. The server itself is stateless and can be replicated to handle the request load and especially for fault tolerance. Typically, in a highly available cluster, the API server is replicated 3 times. Since the API is the only way for clients to access the cluster and ITSI on the backend, it must be properly configured to be accessible by those clients. Let's go and explore those API servers in action. I created a Kubernetes service inside of Azure portal. This service is available on this specific API address that you can see here. So it's synergia -AKS -DNS and so on, so the classic name that you get. So here you will see that you also have different Kubernetes resources. So all of this functionality that you can see here is available if you know how to communicate with the API server behind the scenes through the REST interface. So you can implement this kind of functionality on your own, and you can, of course, do service-less workloads. So everything that you can do, you can basically do it very easily. So in order to prove this, we have a really nice management dashboard that you can then use, free management dashboard called Portainer. And Portainer has an implementation of these APIs inside of the Azure cluster. What I did was, here you will see that you have a Portainer namespace. And if you go inside of the workloads and map it namespaces to a Portainer, you will see that there is one deployment already running with that specific Portainer that has pods inside. So I exposed that specific pods in with a specific IP. So I mapped a name to that IP that was exposed. And if I go to Portainer.Vrhovnik on port 9000, I get inside of the Portainer itself. Of course, I did sign in, but I pressed the checkbox. Remember, that's why it didn't ask me for username and password. If I go inside of this cluster, I can see all of the functionality that you saw inside of the Azure portal, a little bit more concise, a little bit more feature rich. So I can go inside and see, what is inside of a specific namespace and so on. So how does this work? So how you can implement this kind of functionality on your own? If I go inside of the kubectl and do kubectl.exe and then say give me information about the current cluster. When I logged in the first time to that specific AKS in Azure, this is easy because you can go to the overview tab, press the connect button, and here you have the instructions how to connect to a specific cluster, AZA, AKS get credentials. So I can either use your online version or I can use Azure CLI. In this case, I'm using Azure CLI. And when you do that, you get Azure kubectl configured in order to connect to that specific cluster. So, if you don't have kubectl installed, you can do AZ AKS and then install minus here line, it will basically pull down all of the necessary tools in order to connect to that specific part. So what we can check with the kubectl is what kind of API versions do we have available. So if I do this call, I will get back the information what kind of API versions I have available. And here you see that I have v1, and then I also have apps v1, which is something that I'm using all of the time. And then what I can do is also say that I would like to get IPA resources back. And here, when I do this, it will kind of show me what kind of APIs do I have available on this cluster. So if I do then select string and then as, for example, pods, and do the execution to that specific, you will see here that I have then a pod with a name of PO, which is really cool. So specific cluster, all of the information to connect to that cluster is in config file. So if I do config view, you will see that I have inside of that information a config. If I do flatten, for example, you will see that it contains minus flatten. It contains also information about access. In this case, I'm using client certificate data, which means x.509 certificates in order to access to that specific cluster. If I, for example, execute get pods, in this case, you will see that I have 0 pods. But if I do, for example, inside of the namespace app, you will see that I have, for example, this web pod. If I copy this one and do kubectl exe get specific pod with that specific name in the namespace app, and then use specific verbose tag, and for example 6 in this case, and execute command, you will see that what happens behind the scenes is that config gets loaded. Let me zoom in a little bit. Config gets loaded from C user's kubeconfig file, and then it executes a get request on a specific namespace. So if I go and check, this namespace that you see here, inside Postman or something else, I will get access denied because, I didn't provide any information. If I want to get to these APIs, since the API is only available inside of the cluster itself, I can use proxy. And when I do a proxy, it will basically forward all of the requests to the cluster that would be there, for example, in this case. So what I can do now is go to the Postman and execute, for example, 8000, localhost 8000. And when I send the request, what I get back is a list of all APIs that are available on this cluster. So if I zoom in a little bit, you will see that I have, for example, API version 1, and then we have something called APIs. So if I go inside and execute, for example, APIs, you will see that I get a list of all of the APIs that are available there. If I want to see all of the APIs, for example, if you're issuing requests to the cluster itself, you want to see what kind of APIs do you have available, and with that I can basically use the Swagger file, and I can call this endpoint, and what I will get back is basically a big JSON file with all of the APIs behind the scenes. So this is something that they can then do in order to check, for example, for pods. I can execute search for pods and see here. You will see how to use, for example, how to get pods for a specific namespace. What I need to do is say API v1 namespace and pods. So if I go here and say I would like to do API version 1 and then execute namespaces and then pods, give me pods for namespaces app and send the request, I will get back information about what kind of pods do I run in a specific namespace. And of course I can go into details and so on and so on. So this is a really neat way how I can connect to that specific cluster APIs. The main purpose of the API server in Kubernetes is to receive and process API calls in the form of HTTP requests. Those requests are either from other components in Kubernetes system or they are end-user requests. The first stage of the request processing is authentication, which establishes the identity associated with the request. The API server supports several different modes of establishing identity, including client certificates, bearer tokens, and HTTP basic authentication. In general, client certificates or bearer tokens should be used for authentication. The use of HTTP basic authentication is discouraged. In addition to these local methods of establishing identity, authentication here is pluggable, which means that there are several plugins implementation that use the remote identity providers. For example, support for OpenID Connect, Azure Active Directory. These authentication plugins are compiled into both the API server and the client libraries. This means that you might need to ensure that both command line tools and the API server are roughly the same version or support the same authentication methods. The API server itself supports remote webhook-based authentication configuration, where the authentication decision is delegated to the outside server via bearer token forwarding. The external server validates the bearer token from the end user and returns the authentication information to the API server. After the API server has determined the identity for the request, it moves on to the authorization. Every request to Kubernetes follows a traditional RBAC. To access a request, the identity must have the appropriate role associated with the request. We will check in the demo how this works out. Kubernetes RBAC is a rich and complicated topic and devote a whole session to the detail how it operates. But for the purposes of this API server summary, let's say that a request, when you process the request, the API server determines whether the identity associated with the request can access the combination of the verb and the HTTP path in the request itself. If not, HTTP 403 response is returned. After the request has been authenticated and authorized, it moves on to an admission control. Authentication and RBAC determines whether the request is allowed to occur, and this is based on the HTTP properties of the request, which means, in short, headers, methods, and path. Now, the admission control itself determines whether the request is well formed and potentially applies modifications to the request before it's processed. If any admission controller finds an error, the request is rejected. If the request is accepted, the transform request is used instead of the initial request, which means, in this case, admission controllers can be many, and they are called serially, each receiving the output of the previous one. It's very similar to ASP.NET middleware, if you know how ASP.NET works. Now, with addition to this standard RESTful request, we have a number of specialized requests that provide expanded functionality to clients, for example, proxy, exec, attach, logs. But we will look into that a little bit later. As with any authentication mechanism, this is basically the first gatekeeper for any kind of programmatic access. The question here is usually, who is the user? Do their credentials match our expectations? At this point in the API flow, we are not yet concerned about whenever the request should be granted based on the user role or even the request comfort to our standards. Basic authentication is perhaps the most primitive of the authentication plugins available to the Kubernetes cluster, just as with the authentication authorization as well as the responsibility of the API server. Now, basic authentication is a mechanism where the API server or API client, in this case kubectl, sets the HTTP authorization header to base64 hash of the combined username and password. Since base64 is merely a hash, it provides no level of encryption for the transmitted credentials, which means that you need to use this with HTTPS. Now, the most typical authentication mechanism that is enabled by the most of Kubernetes installers is client certificates, X.509 certificates. The reason for this is many, but it's basically almost due to the fact that they are secure and may be generated relatively easily. If there is access to assigning CA, new users can be created in short order. When installing a Kubernetes in a production quality manner, we want to make sure that not only our user-initiated requests transmitted securely, but also that service-to-service communication is encrypted, and client certificates makes perfect sense for this use case. But in some cases, an administrator already has access to the system that are capable of generating bearer tokens. You might be able to imagine a scenario where an in-house system grants a user a long-lived token that he or she may be able to use to authenticate to any number of systems within the environment. It may not be as elaborate or standard compliant as OpenID Connect, for example, but as long as we are programmatically challenging the authenticity of that token, Kubernetes is able to verify the identity of that user. Kubectl proxy is a great way to debug everything locally, but when we have an application that we want to deploy in Azure, this doesn't come into consideration. That's because we need to have a way how to authenticate with the cluster itself. Now, to authenticate with the cluster, of course, we can use the config files that we saw earlier, or we can use client certificates. But the easiest way is basically to grant a specific user a long-lived token that he or she, in this case, may be able to use to authenticate against the environment. Now, if we look here, where we have the postman, and we want to get specific information from a namespace application, we want to get all of those spots. If we execute the code directly to the cluster, and we didn't provide the token itself, in the authorization header, we can then provide the token, but here you can see that it's empty. And what we get back is, of course, failure and unauthorized message, which is correct. So how do I get this kind of token? In order to get this kind of token, we need to basically provide or tell Kubernetes cluster who will be the user who will connect and what kind of permission does that user have. So if we go into our folder that are created for these purposes, we can create a service account. And if I open this in Notepad, you can see that this is basically a service account with a specific name that will be used for our authentication and authorization purposes. Since we'll be working with API server, we want to put everything into the namespace kube system, because this is where we will connect and then work with that specific system. Now, this is just creating a service account. And when this service account is created, we need to tell that service account what kind of permissions that server's account have. Now, in our case, because we won't specify specific permissions, which means we can specify either to have access only to get, either to have access only to list, and so on. What I did was I used already provided role, which has all of those permissions already built in. And this is basically a cluster admin role. And then you apply these commands to the cluster itself with the use of command like kubectl apply -f, and then you say service account, and then execute that specific service account. Now, since I already did that, the service account is unchanged. And what I can do is say, give me all of the service accounts that are available on the system. And you will see that there's a lot of service accounts available. Let me do all namespaces to see all of them in all of the namespaces. And this can be quite a few. But if we, for example, grab it with Bojan V, you will see that specific account is available in the kube system namespace. And the same, of course, applies to the same functionality. Kubectl apply goes with the cluster role binding. Now, in order to get the token back, all of the information inside of the Kubernetes cluster is saved in secrets, base64 encoded, and we can get those secrets with the use of describe option. So I wrote a small script where basically it gets a token from the kube system. So if you search, for example, for all of the service accounts and you do describe, you will get the name of the secret, and then you can easily use decode. And let me execute this code. Then you can easily use base64 decode to get that information back. So if I go inside of the code, let me clear the screen and execute this specific command, and then do echo so that you can see the token itself, and then copy this token and then go back here and provide and paste in the token itself and send the request, you will see that I get back the results of that specific request. Of course, in order to test the functionality of my code and open a simple program file, what we can do then is with the use of API calls. In this case, if I go a little bit down, here you will see that I have a code, HTTP client, and then the bearer token, and then the execution of the request to the server. And here you will see that I'm doing the same stuff. The only difference here is that I'm providing the necessary information through environment variables. So if I go here and edit configuration and go to the environment variables, you will see that I have the same functionality here, you know, the bearer token and the URL to that specific cluster behind the scenes. Now, since I execute a classic HTTP call to the server, what I will get back is a string. Now, you have a lot of different services online available that can convert JSON to C# classes. And I did the same stuff. So I took the output of this call, this specific call here. And then what I did was generate classes. So these classes here, these pods, is a generated class from that JSON string. So now what I can get is a nice object, a lot of classes that I can then use inside of my application with these specific APIs. If I execute this code, you will see inside of the output the names in a namespace app, all of the pod names that exist in that specific namespace. As we saw, REST API can be challenging. There are new protocols to be implemented, change APIs to take into consideration complex JSON objects to maintain and check for errors. Now, client libraries can solve those problems. Now, often it handles common tasks such as authentications for you. Most users can discover and use the Kubernetes service account to authenticate if the API client is running inside of the Kubernetes cluster, or can understand the kubeconfig file format to read the credentials and then the API server address as well. In our example, we'll be using .NET version with the package Kubernetes client production. You create a .NET solution, add a package, get kubeconfig file to connect to the cluster, and you're good to go. It is a great library to leverage and explore in more details. It's not for using it to interact with the cluster itself, but for learning from the source itself, because it has a different techniques, especially with streaming features, for example, watch functionality and how that is implemented. The API server actually supports two different streaming protocols. It supports SPDY protocol, which is SPY in short, as well as WebSocket. Now, SPY is being, replaced by WebSocket, and the basic protocol for this streaming is as follows. Every stream is assigned a number from 0 to 255, and this stream number is basically used for both input and output. So that means standard input, standard output, standard error as well, which means 0, 1, 2, and conceptually models a single bidirectional byte stream. But for every frame that is sent via this WebSocket protocol, the first byte must be a stream number, which means 0, 1, or 2, and the remainder of the frame is the data that is traveling on that stream. So let's see this in action and dip a little bit deeper into the Kubernetes client library to see what this stuff can do. So let me go back to the development environment. Inside of the development environment, I have a project kubectl console, and inside of that, I'm using the libraries, the kubectl Kubernetes client library for C#. If you go into the NuGet, you will see that I have an installed package inside of my project, which is Kubernetes client, and I'm accessing the authentication via kubeconfig file via useful library build config from config file, which takes the .kube/config/config file with all the authentication mechanism and authenticate the user against the Kubernetes cluster. And then I'm accessing the client. Now the API itself is built with C# structure in mind, which means here you can see that I have a call to get all of the namespaces back. So let me execute this code. You will see that I will list all of the namespaces inside of my cluster. You will see here that I have all of the namespaces that are inside of that specific cluster. So let me continue. So the next part where we will step in is basically the list namespaces, list pods in a specific namespace. So I will list all of the pods in the namespace app. So let me execute that specific part. So you will see that I will execute the call. Let me go inside of the code, press F5. Here you will see all of the result of that call. I even get the associated labels with that. Then creation of that specific objects inside of Kubernetes with the use of this library is basically with a very similar as how we're doing the stuff with YAML file. So here you can see that I have a namespace with metadata and a specific name, and then I have pod below. So I'm creating a pod inside of a specific namespace. This pod is named Nginx with a specific image. And if I open YAML file, this is very similar stuff as we are doing this with YAML, so that there is a consistency between the API, between the YAML file as well, which means in this case you're seeing that I have spec, containers, metadata, and if I go back, I have the same stuff here. Now this is normal CRUD operations, which means it calls an API, a method in this case, create namespace pod async with a specific properties. And if I execute this code, you will see that this will be created. If I go back to the kubectl and say kubectl get namespaces, you will see now I have a namespace that is called test in this case. Now inside of this namespace, I also get a pod, which is Nginx test, as we saw, which is already running. Now if we go back and press enter in this case, what we can then do, a little bit more interesting, is that you can even connect and execute specialized requests. In this case, I'm executing inside of that specific pod. So this is the same as I would be doing kubectl exec in a specific pod, which is Nginx minus test with a namespace test, and then I would like to execute environment variables. And this way you can do the same inside of C# code with the use of this approach. So I will execute specific pod and see the same result return back. So, but we can do even more. So we can, in this case, what we can do is press enter, and what we can do is even delete objects from the cluster, and then let me press F5 to delete the namespace, or the namespace was deleted. And but this is only API calls. I can even then, if I want to, I can load objects for YAML files. So earlier I showed you this YAML file, so I want to get all of the information from this YAML file, so I can use a way with the YAML class, which enables me to load the YAML file and then show what is inside of that YAML file. So let me execute that, and here you see that I have a pod, which is YAML file, and then I can even watch on the specific actions inside of that specific Kubernetes cluster. So if I go back, so here you see that I'm watching a namespace default, and if I go and execute this code, what you will see, I'm now watching. And if I go back to the kubectl and do kubectl get pod in the namespace default, and now what I will do is say kubectl delete pod web, and now when I do this, you'll see that in this case that pod was modified, and then of course the pod, when the deleted was occurred, the pod was deleted. So we have a really nice APIs where we can do everything that is possible inside of the Kubernetes cluster. But the most interesting part here is basically the use with some business processes or some business applications. Maybe you have a WPF application, maybe you have Windows application, or maybe you have a web application. So what I have here is a web application. And inside of the web application, I have then implementation of these services. So the same stuff that we saw, the only difference is that instead of loading from a local system, I'm loading the kube configuration from a storage. So I have an implementation which downloads the kube config file from a storage, and then I'm building it from a stream, and then turning, of course, that is back to the client. All other implementations are very similar. So if I want to list namespaces, I have the same implementation. Where this comes into play is when we have, for example, scenarios. So if I go inside of the CRUD, inside of the CRUD, I have a scenario. Imagine that you have a store which you want to publish and create a trial of that specific store. You can easily do that with the use of this kind of functionality. So let's say here we have a namespace which is name-test, and then we create a namespace, we create a deployment with our configuration, and then we create a service. And what we do is we expose that service to the public world, which means what we will get back is an IP. We will give back an IP, which we can then, redirect users to that specific URL. So I will go inside of that specific web project, run it, and you will see this in action. So this application is available on localhost 502. This will now execute. I will log into this application. So here I have a dashboard. It will automatically log me with the Azure account. I can do the same step that I did before with, for example, list namespaces, see the pods. Or what we can do is now execute the scenario. So here we will put in a name, Synergia, and when I press scenario create, what will happen behind the scenes, it will create kubectl get namespaces. It will create a namespace Synergia test, and inside of this Synergia test, it will create pods and also service, which will be then exposed to the outside world. So here you see that I have already a running pod inside of that application. Now if I go and instead of pods say give me back SVC, you will see services. You will see that I have a load balancer, one service that is exposed to the load balancer on IP, this specific IP. And if I go back to this store scenario, you'll see that I already have a link here. And if I open that link, I have a web page that was created on the fly with the use of these libraries. On this slide, you'll find some great resources to dig into the API server a little bit more and to see what can be done additionally as well. Are there any questions? Thank you for listening.